this is the video for the Lumberjacks, our presentation of our criminal database software. We're not completely functional, but we're going to show off what we do have. So I'm going to start off first. I'll go in and run the program. What I'm going to attempt to do here is run scenario 1. So as you can see here, we get some errors coming up. This is just to do with the type coming in for foot size and one other thing. It's still functional. So for scenario 1, we need to log in as a detective. So we'll use one of our preset ones. And that will be Brooks. And we'll set the password, which is just password. And then we can log in with that. Now, next up, we need to enter a new crime into the system. So we're going to try to do that. And that is going to be robbery at gunpoint. Now we're going to create it. And it immediately stops there and goes back to the enter new data screen. This is not functional yet. Now, what I'm going to do is try to stop the program. And now we're going to try to run scenario 2, which is where you are looking for the information on the crime. This one's not going to work. Our search is also not functional. We got very close to having it to run, but we ran out of time. So once again, I'll log in and show off if this works. Right, we can go to search, and we need to find anyone with a dove tattoo. So right now we can't set that yet because we haven't gotten around to that. So I think I'll go ahead and hand this off to my team for the rest of it for scenario 3. If any of y'all want to take it, I can just share your screen.
Can we, with the case details, do we have a printing screen ability? Or I don't believe we have any of the scenario 3 stuff.
We can run people, but we haven't done the case yet.
Yeah.
So we should probably just move on to the UML.
Okay.
Or if we could show off some of the code itself, what we have.
Yeah. Let's go ahead and do the UML first. So whoever wants to share the screen and show that off first.
I can share off my part of the UML if you want.
Okay.
Is that coming through all right?
Yep.
Yeah.
All right. So for my part of the UML, I pretty much have this whole structure right here. The center of it is going to be the screen. This, which gets functioned by the UI, is essentially what gets passed around between all the different classes, which holds data and displays stuff to the monitor. Now, primarily what UI is going to do is it's going to connect to screen, and it's going to use screens.next method to sort of cycle between each screen, which allows the user to make decisions to which screen to go to. The different types of screens that implement this abstract class are entidata screen, editor screen, trans screen, and result screen. And essentially the differences between them just allow them to either display data that allows it to be edited, simply displays data and allows the user to move on. Entidata screen is for when you're specifically entering data for like setting username and password, and the result screen is for when we perform searches and other stuff like that. It'll return the partial results. In order to switch between these and for it to be more easily done, I use this telephone and switchboard class, which essentially just allows it to take a string, use that string to call a method stored in either UI constants or facui constants, which basically just details information on how certain screens get created. For instance, UI constants contains a welcome screen method, which sets up all the text for what a welcome screen looks like. And the telephone allows the independent screens to actually call upon that. Fac calls allows the screens to call upon the facade. So for login, logout, create account, and stuff like that. When called, it'll go into facui constants, which holds the facade, and then call the different methods accessing it. So for instance, login in the code will actually take the data stored in screen, pass it to facade, and then allow the facade to return whether or not the login worked. And then screen calls and fac calls hold the different commands for that. And I believe it's all held together by the UI, but I believe that's it for my part of the UML. So I can stop sharing that if someone else wants to share their part of the UML.
Want me to go next because it's connected to the UI? We'll just go from left to right.
All right.
All right. Let me go ahead and share my screen real quick. All right. So what we got here is the facade. It connects from the UI to the facade. Basically, what this does is it allows everything to basically intertwine nicely. I don't have it connected to like officer, POI, victim, although it should be. The reason why I set it this way, where it was just connected to these three, is just kind of an example that it connects to every single thing. Because what the facade does is it basically makes the inner workings of all the class combination, like the connections between them, it makes them look nice and all tidy in one spot. So it actually does connect, like if you can see here, it calls upon like person, crimes, users, criminals, POI suspects, all of these things. And it gets the instance of those to then be able to like find the person, check the person, edit the person, add the person. And this is just, again, calling upon the class, which the class in itself will end up having the algorithms to be able to conduct that. So.
Oh, that's not it. All right, so can you guys see my screen?
No, not yet.
All right, that good?
Yep.
There we go.
All right, so
Wow.
I'll start with the crime. So the crime class holds a bunch of variables such as like user, stuff like that for the crime, and then also has array lists for each type of person that's associated with the crime. Also holds an array list of evidence for any evidence that could be associated with the crime, and it has a bunch of methods, accessors, mutators, and stuff for all the variables. And then so for the people, it starts with the base class for a person that has set variables. And then from the person, there's an officer, a person of interest, a victim, and a witness. And then from the person of interest, a suspect comes from that, and then a criminal extends suspect. And I chose to do it this way because POI, suspect, and criminal all need the same information, but suspect is more specific than POI, and criminal is more specific than criminal. So this way it just allows all the data to stay nice and tight. And then a hospital report is used by a victim, and yeah, and then the last thing is just the user just keeps track of who's using the the program and what they're doing.
All right, and I'll get on to mine now. So I personally had all of the JSON interaction stuff. The big one I want to start off that both data writer and data loader are dependent on is data constants. So each one of these is a protected static string, and each class has its own variables that contribute to helping both data writer and data loader function. So crimes, criminal evidence, goes down the list. Most of the ones per person are reused in the people objects like victim, witness, and especially in suspect and criminal, because those inherit so much information. Now, next up is going to be data loader, and up at the top I included a private static variable that was string, and it's a delimiter, and all it was an empty space. And this is used to split up a string array, or split a string into a string array, and this was so that way I could intake objects. Now, for all of the methods
Hey, real
I have,
quick,
what's that?
real quick. I don't think you're sharing your screen.
I know I'm not.
Oh, he's recording it. He's
I'm
fine.
recording it.
Oh, okay, gotcha.
So-
Never mind. It's late. Sorry.
All right. So for all of the functions, or I should say methods, I've got load for every single type of object that we use, and then for all of those, they store every object pulled in from the JSON files in an array list, and this is what's returned. And then lastly, I've got data writer. So once again, for each object, I have a save users method, which is a void static method. And what this does is, this is really the one that does the file IO. It opens the file and then flushes the information to the file once it's gathered from our next methods, which are the get user or the get crimes, all the get JSONs. And they take in an object from the save methods, and they return a JSON object so that the save methods can go through and add each object that needs to be added into the JSON files. So I'll shoot right over the code for just a second, and you can see for data loader, all of these methods are implemented. They're all the same. I know I attempted to make this its own function, so that way there wouldn't be such repetition in the code, but that ended up not working out due to different types of, say for example, evidence, array lists, and there were a couple other issues that came from it that just didn't want to work. And then in data constants, it's all just the same protected strings. And then lastly, in data writer, you can see where it goes through the list of objects, and then the objects are created right here. So for myself, that's it. Does anyone have anything else they want to show off?
Should I show off the code for the UI?
Sure. I don't know if we have time, but sure.
How long do you say we have? What did you say we have?
It's a max of 12 minutes.
What are we at right now?
I'm not sure.
Well, I can go through this real quick. You can see my screen?
Yep.
Okay, so the UI is the one that holds the main method, which is going to do this. The main function of the UI is that it's going to call this display loop, in which displays the screen, going to grab input from the user, and then goes to the next screen. And if it fails to go to the next screen, the loop stops. You can see in UI constants, we have all of the declared information for each kind of screen. For instance, the very first screen, welcome screen right up here, simply declares welcome, allows you to exit, log in, and create an account. And then the options for how you to do that are linked there. And for something like login, I believe that's down here, you'll have some prompts for username and password and different sort of options down there. Now, the main way this is going to function by passing is the screens is by using the screen abstract class. Mainly, all of this is just sort of, these are the main two important ones, display and next. These get implemented by things such as trans screen or transition screen. This is a screen that just displays text and then allows you to pick an option to go. Editor screen is one that actually allows you to change information like username and password for logging in. And then to data screen simply displays a singular piece of data and allows you to change that one at a time. And then just to quickly describe how these actually call the different methods. Using this telephone switchboard class, it's going to essentially allow you to call different groups of functions such as fat calls and screen calls, which hold these commands here. When you call them using strings, it'll be linked to the method in UI constants or fact constants over here. And when passed to screen, it'll do different things. So for a quick example, if we were to call welcome, which starts at the beginning, it'll call UI, it'll jump over to the welcome method here, create it, return the screen back to the original screen, which then links it to the UI and display. And UI and fact constants on all these just denote the actual methods. It's pretty quick, but I think that's the roughest breakdown of that code that I can give.
All right. Well, if that's it, that's our criminal database software as it is on March 29th. We plan to get it fully functional. That's the plan. We weren't able to get it fully functioning up until this point, but we think we can get there soon. So that's it.